Okay, thank you, Olmo. Thank you, everyone, and well, I want to congratulate these people that is making this great. It's a great idea, and to have a place to meet with people that love engineering, science, or technology, or whatever, is great. So, thanks for having this here in Maccabi. Well, I'm Pablo Garcia. First, sorry for my English. I'm from Spain. I'm a teacher. I'm a computer engineer, but I'm in the exchange program of visiting teachers. So I'm teaching this year physics in PSDA, as Somo said, and well, I have tried to bring my ideas from that I'm working within Spain to the district, so I can teach physics, but in a different way. Okay. So that's my background. I have a bachelor's degree and a master's degree in high-speed networking. So I have been all my life through computers and weird things, no? But like I'm teaching 16 years ago. I started teaching, and I'm in high school, and I'm teaching in the university too. But I spend my 90% of my time teaching high schools. So we meet with some teachers that we love electronics. We have to teach electronics in high school, but we found a problem. It's difficult to get the students to understand a lot of things, and it's difficult to practice them in the classroom. So we designed a shield for Arduino. I'm going to talk a little bit about our shield. I'm going to talk about a little bit about Arduino. I don't know if you know about Arduino.
No.
Have you been working someone with Arduino so far? Okay. Let me just turn off here. Okay, we'll talk about Arduino later because it's the main board that we are using for teaching this. But well, wait a moment. Well, we are 4 teachers in Spain. We are technology teachers. It's a subject that you don't have here in the United States, but it's a mix of physics and math and science and engineering, and we use it for kids from 12 to 17 years old. So that's the age, the range that we are working with. But Arduino is used everywhere. So if you Google or you YouTube Arduino projects, you will find a lot of great things. I don't know. Okay. Okay. Here we are. So the shield we have designed is called EduBasica. It's a Spanish word made for education and basic. Like it's an introduction to the robotics and the electronics. So and it's an educational shield. This is our website. It's Prácticas con Arduino, like labs with Arduino, practice with Arduino. .com. Everything is in Spanish. So, but anyway, this is a regular physics or electronics classroom. So this is the mess we find every day when the first period enter in the class, and you have to take out everything and all the resistors and all the wires and the breadboards and the batteries and the relays. This is what we find every day. And then the kids start breaking the LEDs. They blow up some lamps. They do a lot of crazy things with electricity. So even we are working with DC, so it's no danger there, but it's always a mess. So we have been working a lot of years, and then we knew Arduino. That is a microcontroller, it's programmable, and you can do a lot of electronic things with that. So we said, can we put a lot of these components in a single board, and we can use that board for teaching in our classes? So this is EduBasica. You have a lot of components, a lot of different things that you have here. It's difficult to break them. Okay, you can do it, of course, but it's difficult to do, and you can do a lot of labs with these different practice. You can build robots. You can use sensors, a lot of things. Okay, so what is inside? I'm going to talk in detail later, but we have LEDs. So So they can program how to switch them on, off. They can do a lot of different things like sequences or flashing or whatever with LEDs. They can use a transistor. They can like switch on or off motors or relays or things that need more power. They can use an H-bridge, like an amplifier for powering motors to move a robot, for example. They have a switch, so you can practice with a switch. You can practice with digital signals like on, off, 1, 0. Like, yeah. They have a potentiometer and LDR, and there's a lot of easy connections. So all the wires we are using is like all condensed there, okay? And it's Bluetooth ready. So there's a tiny Bluetooth modules that you can connect to Arduino, and we have built a easy connection for you. Only have to connect it, and that's all. You don't need wires, and that's all. Okay. So that's how it works. It's a shield that is connected to Arduino. All the pins are made like this. So you can to show it you this. This is the shield, okay, with all the components, and here is Arduino. That is the brain. It's like a tiny computer. Okay, it has a microprocessor, it has a memory, it has a lot of things that we are going to, and this is just connected like that. This is the Arduino, and this is how you connect this board over it. So you have a lot of components that you can use it in class, okay, for every day. You program this, and then you make whatever you can imagine, okay? We are going to see some examples later. Okay, so what is Arduino? Arduino is a very famous platform now. In 2015, they have it's a 10th anniversary, so they started in 2005, and it's as you can see, it's a very small device. Okay, it's a very small device, but it has a lot of power. And there's even an Arduino Nano and Micro that are like this size, okay, smaller than this, and they have the same thing, the same connections and everything. So you can find there's even Arduinos for wearable things, so you can design your own clothes with LEDs and things that are moving when there's music around or something like that. Okay? So why is this so famous? It's super easy, programmable. So they studied as a platform for using in Italy and in the north of Europe for people that are in fine arts university. So they would like to play with lights, with sounds. They are artists, but they don't know anything about electronics. So the teachers, the technology teachers that were assigned there, they were thinking about, okay, we can build something that makes very easy to connect things and to make them like interactive with the world. It's connected via USB to the computer. It's programmed in C, using a programming language that is very it's known everywhere, and you can use like visual and block programming, so it's easy for kids. Even you can only drag and drop different blocks, and they are connected, and you generate the C code if you don't want to enter the code. It has connections to the physical world. That's the best thing. They have like pins that we are going to see later. A lot of pins. When you connect things, that it's sensors all the time. You can get light, you can get sound, and with that readings, you can program the Arduino to do something, to move a motor, to open a gate, to beep an alarm, whatever. There's a new culture. It's called Internet of Things. I don't know if you have heard that you can connect your refrigerator to internet, so you can be at work and see if your refrigerator is low temperature or your coffee maker needs to replace water. Or you can do this with Arduino, okay? And of course, you can use it for robotics. And what is robotics? Why is so kids love this, okay? If I'm in a classroom and I take this and they want to build this, it's awesome. They are learning electronics, they are programming things, and they are building these kind of things. So it's like, for them, it's like, hey, where's the next class? No? It's a different approach. So you can see a lot of excitement in their classrooms. So this is Arduino. I'm going to talk a little bit about Arduino so you can know how it works. It has a digital inputs, outputs. Digital means it only gets two values, high, low, 1, 0, true, false, whatever you So think about the switch of light. I can turn the light on, I can turn the light off. That's digital. So that's the thing that these pins can detect. These pins can detect if something is pressed, if something is activated, like it's activated or it's not activated. We have analog inputs. This is more for like temperature, for movement, things that are not true or false, that have a long range of values. Okay. We have power because all the things that in electronics needs power. We need 5 volts. These work with 5 or 3 volts, and ground pins. And you have the connection for USB and the power connection for a adapter. Okay. So the USB receives it's a serial connection. So if you connect Arduino to your PC or your Mac, you create a serial connection. So you can send data and you can receive data for Arduino. So that's great. You can connect something here and you can read it from your computer. If something is pressed, or you want to know the temperature in the room, or you want to know if something is moving, or you can read it from the serial connection, and also gets the power. So you connect here, you have 5 volts. Okay, the connection for the power is for a DC adapter. It allows from 9 to 12 volts, so it's a wide range. So you can use a lot of different DC adapters from the routers that you have at home or whatever. It provides 250 milliamps. Okay, and now the digital input and outputs, as I told you, is 0 or 5 volts. So 0 is low, 5 volts is high. That's what you get. Okay, low, high, yes, no, true, false. You can read from the sensor, or you can write to a device. So you can say, you can tell a servo motor, as I am going to show you later, to move to some position. You are writing. You can read from a sensor. You can read if some button is going to be pressed. So if you press a button, you're reading from there. Okay. It works with 40 milliamps, so it not allows you very high charge, but you can use like transistors. I think that can make that bigger, as we are going to see later. And you can connect this a motion sensor, an ultrasound sensor, a switch, or whatever that gives you digital things. The analog inputs, you have 5 of them, 5 things. You can connect 5 things simultaneously. And it's an analog digital converter. It's a DAC. It's 10 bits, so you have from 0 to it's 2 to the power of 10, so it's 1024 bits. 10 bits is from 0 to 1024. Okay, it converts the 5 volts to these values. So Arduino can read a long range of values. It's not 0 or 1, true or false. Now it's like from 0 to 1024. Okay, and you can read from ports, from light detectors, from temperature sensors, a lot of things that have a long range of values. Okay, almost everything, all the physical magnitudes are analog. So we have to convert them to digital using this converter that includes Arduino. So examples, you can connect easily to Arduino a motion detector, like the alarms that you see everywhere. It's a motion detector. You can connect it with 3 wires to Arduino. But in EduBasica, you can connect it directly because we have provided 1 pins to connect it. So, for example, this is the same thing that I'm showing you there in the. Okay, this is a motion detector that can be connected with these 3 wires. Okay, to Arduino. So you only have a voltage input, a ground, and a signal output. So only 3 pins, and 1 wire is going to tell you if something is moving or is not moving. Okay, so this is digital. Okay, I have some samples here so you can see how to manage different relays. So with this, the relay you can like power wherever you want. Okay, wherever you want. You want to start a car, or okay, you have a lot of power if you switch on or off 1 relay. So it's very easy to control big things. You have a 40 milliamps in this output, but you can switch on or switch off a relay, and you can switch on or off whatever you want. Okay, you can connect like sensors. This will be a sensor, a touch sensor. So it's a pressure sensor. You can touch it with different pressure, and it's going to move a motor. It's an example. So you have an input that Arduino is going to read, and you have an output that is going to move a motor. So for example, you can touch it like this, and this motor is going to be moving, following your movement. Okay. There are thousands of examples over there. So how do you program this? This is a little microcontroller, and you can program it. You have a lot of different interfaces. I have two that I've been using for young kids from 10 years old or 11 years old. You can start using these blocks that you have to drag and drop. That's all you have to do. And there's like the conditionals. When space is pressed, then digital is on, and then repeat until, so you create the structure of programming for kids. That's great. You create and you teach them how to think, and we all know the advantages of programming and what is for kids to learn that. So you have a lot of different things that you only have to drag and drop. Like when you press something, or if you are reading from a motor, or you are writing, or you are moving. And you can see an Arduino here that is showing you all the values that you are getting in there. This is S4A. It's called Scratch for Arduino. The Scratch is an environment created by MIT, and this adaptation to Arduino was made in Spanish university. So it's great. It creates a very easy interface for kids. And there's another one that is called ArduBlock. You can see it's almost the same. You have blocks with control, with pins, operators, so you can create a loop and readings and writings, and so a lot of different things. And this is the original interface for Arduino. It's the one that I'm going to show you in a moment. And it's C. If you have ever programmed in C, that's how it looks. It's C. It's maybe you'll see that, oh, for kids that I've been programming with 14 years old kids in C, and there's no problem. Okay, it's very easy. So that's a good thing. Okay, so EduBasica, as I told you, is a shield for Arduino to make everything easier. Of course, that if you are teaching electronics, you want for them to connect everything, because okay, if you give this to them and everything is there, it's nothing there, but it's the first approach. So you can start with this, you can get all the theory, you can try it, and when you know how to manage everything and how to turn on and off a LED, and you know that an LED needs a resistor, and then you can jump to the next step is you don't have to use this, and you can do it by yourself with the breadboard. Okay, but here is the first approach. You can use it for teaching, and then you can use it also when you know how to do it and you don't need a breadboard anymore, because I think that at the beginning you don't know anything, so you can use it. Then you can learn how to do it later, but when you know how to do it, you don't need to be all day wiring everything. No, you know how to connect it, but you have this, and you can do it very, very easy. So you can connect a lot of things directly here, or here, or here, and you have a lot of things. So let me explain you in 2 minutes what is here in this shield. You have direct power pins. So if you connect something here, you are getting ground, 5 volts, and the signal. If you don't have this and you have Arduino, you have to connect everything to only one pin. Arduino has only one 5 volts pin. So if you need to connect 5 things, you need a breadboard. So you can connect here a lot of things because you have a lot of power pins. That's great. You can control a servo motor. This is a motor that you can control by degrees. So you can move it to a certain position. It's a very accurate motor. So you can say, okay, go to 90 degrees, and the motor goes straight, or go to 120, or whatever. So you can connect it directly here. You can connect the Bluetooth module, as I told you, in this part, because these 2 pins are connected to Arduino communication pins. So you can connect wirelessly to Bluetooth. You have a switch, so you can try with digital things. You can teach the students how to do that, but you can just get some reading for a switch. You press it or whatever. You have LEDs, as I told you. You have 3, red. The color is not good here, but it's red, green, and yellow. So you can do a lot of practices for them to, okay, do like a traffic light, or you have to do like a signal Morse SOS, or you have to do a flash, or there's a lot of things that you can do with that. You have a potentiometer here, the 10K potentiometer, so you can have an analog input, so it's connected to an analog input. And this LDR is a light-dependent resistance, so it detects the ambient light, so you can do a lot of projects like detecting when it's night or when it's day, or when you have to turn on some lights or whatever. You have extra analog or digital connectors, because the analog connectors can be used as digital too. Remember that they are only digital, analog to digital conversion, so they are really a digital thing, but okay. You have an auxiliary power input and output. You have a power switch that is going to manage the current inside the board. So if you turn it off, all the motors, everything is going to be without power. That is great in class when you don't want to break anything before checking it off. You put it off and everything is safe. Okay. And then when everything is clear and you are sure that everything is okay, you can put it on and everything will work. Okay, there's a transistor here. It's a TIP121. It gives to 5 amps, so it's a lot of power here, and you control the output here. It's the digital 6, number 6. You can put it on and off, and then you are going to get a lot of power here. And you have 2 more connections for 2 motors, so you can manage like 3 motors and servos at the same time. That's why you can use it for a robot like this, where you have 4 wheels, so 4 motors, and you have a servo here that is moving a sensor, and you have another, so you can connect a lot of things. So this is EduBasica, and we are teachers. We have been teaching a lot of time, and we say, okay, it's enough. We have to find some better way to spend hours there in the lab, taking all the things apart, and okay, so. And we developed a book. I have a video here, but I don't have an iPad. So I'm going to show you, because we make a book with a lot of different practice and labs. So here is the book. It's an interactive iBook. I don't know if you can, it's in Spanish. But, okay, no. Okay. So it's an interactive iBook. So you have a lot of problems you can work on. There's videos, there's code for using Arduino. Okay. And as you can see, it's not only practice, you have theory, and you have like videos. You can see, this is a potentiometer, how you can connect things, or okay, how you press the button, okay, in EduBasica. So this is analog electronics. So we have a lot of chapters that are adapted to all the chapters we have in this subject, okay?
This is only Spanish?
Yeah, we have it in Spanish. We are translating a lot of things, but it's going to take us a while. So for now, it's only in Spanish. We have been using this for last 2 years in the classrooms, okay? So you have a lot of things about, okay. You can see videos. So it's an interactive, it's an iBook. So we have this the same in PDF. It's not the same, of course, but okay. So that's a lot of theory, and I'm going to show you how it works. Okay, how we use it in the class, and how simple it is to program something. So I'm going to show you a very easy program. It's called, as I told you, it's in C. So, for example, I'm going to make one LED to blink. So it's only, I'm going to switch it on, switch it off. It's a basic example that is already in Arduino, but we have a lot of sample test, sketch tests that you can upload to EduBasica to work with the students. Okay. So Arduino has three sections, all the programs in Arduino. The first one, you have to declare all the variables, the labels you are going to use in the program. The second one is the setup. As the name suggests, is a setup of a configuration for all the pins. You have to tell Arduino, okay, I'm going to connect you a motor in the pin number 6. I'm going to connect you a light sensor in pin number 5. So Arduino knows where is everything connected. And after that, we have a loop. So loop, Arduino is always repeating a loop. Always, always, always. Okay, it's an infinite loop, and Arduino is always repeating from here to here, all time, forever. So it starts reading the setup, it makes it once, and then it starts with the loop and then repeat it indefinitely. So for example, here, I'm telling Arduino, pin number 3 is an output. So you can write in that pin. You can say that pin is on, is off. Okay, so it's an output. I'm going to say write in that pin because it's an output. If it's an input, you can read from that. So the first thing is that I'm going to use the pin number 3. And what is the next thing? Loop. What are you going to do is to digital write. So you are going to write a 0 or you are going to write a 1. In the pin number 3, in this case, I'm going to write a high. High, it means true. 1, it means 5 volts. So when the program gets here, Arduino gives 5 volts to this pin. So anything that is connected there is going to be on in that moment. Okay. Then the next instruction is delay. So wait. The program is going to wait 1,000 milliseconds, 1 second. So it's going to give 5 volts during 1 second, and then I'm going to put it down. I'm going to put it low. I'm going to put it 0 volts. So it's going to be off for 1 more second, and then it's going to go again, and it's going to put it on, wait, off, wait, and then it's going to go. So it's going to put it on, put it off. So of course, in digital pin number 3, I have to have something connected. So this is the result. If you connect something to Arduino, and you upload this, you see this. Okay? So you are putting on and off every second. That's easy. So it's only a digital write. I'm writing digital. So this is the first thing that you can do, is the most easy thing. Okay? I'm going to load another one. For example, the same thing but for different LEDs. We have 3 LEDs in EduBasica. So what we are going to do is to make some like different configuration of on off. First thing, we create, not like before that we use the number, we are going to use a label. So we are creating the variables in the program. So we call LED G, green is the number 3, LED Y, that is yellow, is number 4, and LED R, red, is number 5. So we are not going to use anymore number 3, 4, 5. I'm going to use LED G or LED R. Or so setup, the setup is going to be like 3 pins. We have to say, okay, you are going to have an output in number 3, an output in number 4, an output in number 5. That's all. And then at the beginning, you are going to put them all 0. So it's going to be off. I'm digital write in all the 3 LEDs low. So it's going to be off. And then what is going to happen is going to go to the loop. And the loop is only this. It's going to be to make a sequence. It's going to wait 2 seconds, and it's going to make a flash. Of course, you can make it. You can program it for your students, or you can enter in this later. But the flash, what it makes is put it on and off, and the sequence, what it is moving sequencing. Okay. So what I'm going to do now is to load this to Arduino. Now Arduino has the same program as before. It has an EEPROM. It's a memory that is there until you rewrite it. So it's waiting for you to rewrite. I'm going to rewrite the memory, clicking this. It's going to rewrite, and now it's loading. That's all. So now the program is in the controller. And this is very simple. Now it's flashing, now it's sequence. Okay? But you can do like 20 different practices with this with the students. Okay, you have to make this, I don't know, Morse. You got the code in Morse. You have to only put the first and the last one. You have to put a lot of different sequences. So they have to figure out how to make the delays and when to switch it on, switch it off. It's amazing. You can have like 1 hour the kids programming, switching it off, switching it off. It's very easy. Okay, for example, to test the switch, we have a switch in number in digital 2. So now the difference is that we are going to read. We are not going to write. Well, we are going to write too, but we are going to read from digital 2. And we are going to do something. We are going to, okay, we have a switch in the number 2, and we have an LED red in number 5. So when I press the switch, the number 5 is going to be on, and when I release the switch, the number 5 is going to be off. So I'm going to create a label that is called estado, that is going to store if it has to be on or off. The setup, again, always, we have to tell, okay, we have an LED that is an output, but we have now a switch that is an input. So you are going to read from the digital port number 2. So now the loop is going to be a digital read. So if the digital read is high, so if the switch is pressed, you have to write high. So if the switch is pressed, you write high. If the switch is released, not pressed, you write low. So this you create like that mind that all programmers we have, that okay, the structure in the mind that you can use for a lot of different things, and the creativity and all the advantages that the programming has. So I'm going to load again. Now it's loading, and now it's waiting for me to press. Now Arduino is checking pin number 2 all time in a loop, an infinite loop. When I press, okay, it's going to light number 5. Easy, okay? So this is the digital read, and we haven't used a wire, we haven't used a resistor, we haven't broke anything, okay, for now. Okay, this is an analog reading. Okay, so an analog reading is that we are going to read something that is not high or low. It's something that is going from 0 to 1024. So what we have here, we have an analog pin that is in A0. So the port in EduBasica is connected to the first pin analog. And we have an analog output. What is that? Arduino can simulate analog things. It has values using PWM, pulse width modulation, so it can simulate analog things. It goes from 0 to 255. So it's not so wide that from 0 to 1024, but it can simulate an analog thing. But it's a digital thing, so okay. The first thing we are going to do is we don't need that. As you see, I've not declared in the setup input or output because analog doesn't need that. Okay, so when you have an analog thing, you don't have to declare if it's input or output. You only use them and that's all. So the loop, what it's doing now? It's reading, but it's reading analog. So the function I'm using is analog read from analog input. So the pin 0, the pot is going to be read here. And now the output value, I'm going to map it. It's a you don't need to know that now, but you are going to convert, look, from 0 to 1025 and 23, sorry, that is the input, as I told you, is 2 to the power of 10. But the output, as I told you, is from 0 to 255, so that's why we use this function. So I'm going to read from the potentiometer, that is something I'm going to move, and I'm going to write to an LED that is going to be light, but not on, off. It's going to be more light or less light. Okay, so it's not digital. It's not, the LED is not going to be on, off. It's going to be a little brighter or dimmer. The good thing about this is that, as I told you, Arduino is connected by a serial connection. So you can read and you can show in the computer what is happening in Arduino. So that's why I'm using a serial connection that is going to send me all the data. So I stop talking and show you. It's loading now. Now it's loaded. So what is happening now is that here I have a potentiometer and I have, okay, this is the potentiometer in EduBasica. Okay. Now I'm going to move it. Okay, so you can see that I'm not switching it on and off. No, I am changing, okay, the value of the light. Okay, so you can map it better, or so you can move it, and you can know that this is getting from 0 to 1024, and this is getting from 0 to 255. So Arduino is simulating an analog input and is simulating an analog output. So if you now open the serial monitor, this is the connection. So I'm going to click here, and it's opening in a serial monitor. So you can see. So what is here? This is telling me what is happening in Arduino. It's a serial connection. So now it's telling me that the potentiometer is 0, and of course the LED is 0. If I start moving the pod, you can see that the values are start. Now it's in 66, so the LED is in 16. It's mapping the results. It's not the same number here and here because the scale is different. So now I'm moving it, and I'm going to top value. From 0 to 1023, there are really 1024 values. That is 2 to the power of 10. This is the digital. So you can work with the students using the binary code, and they can learn about these things. And you can see the input and the output. It's okay. It's giving me the highest value, 255. This is the highest value for PWM. Okay. So it's simulating that he can read analog values and that he can write analog values. That is not true, okay? So this is great because you can always send information to the computer and see what is happening when you are designing some new project and you don't know what is this node is lighting up. Maybe it's because you are doing something wrong. You can see it here. Okay. You have enough, or you want another one? I have a lot of. I have like 1,000 more examples to show you. There's a lot of beer, so you don't have to. Okay. So this is a reading for an LDR. So all the things that I'm using is the things that are included here in EduBasica. Now we are going to read from an LDR. It's a sensor that detects the light level in one room. Okay, so it's used for the farolas. How do you say farola? Lamp. The lamps in the streets. When there's no one guy looking, okay, it's night, I'm going to switch it on. No. You can have a sensor, so you can know if it's day or light, or you can do whatever you want. So what I'm doing now is, look, I'm going to use the analog one because it's where the LDR is connected in EduBasica, and we are going to use again the red LED to show what is happening. So I'm going to do the same thing as before. I'm going to read from the LDR that is analog, and I'm going to write on the LDR. I'm going to use again the same. Of course, it depends on where are you. Now this is in my classroom. This is the values that I'm getting in my classroom from the LDR. Now here I have different light, so the light has to be checked. So that's why I'm going to use this monitor. So I'm going to upload the code, and I'm going to know which are the light that we have here. I'm going to read it now. Okay, it's finished, so I'm going to show you. This is input value. So LDR are reading now 840 and 53. So if I cover this, look, it goes to 999. So I'm just covering the LDR, okay? And it's moving. So I know that the lowest value is 853. So I'm going to change it here, 853. And the highest value is, highest value when it's covered is 996. Oh, so 996. I upload the code again, and now it's going to map all the values from 0 to 255. Okay, now it's, so now I'm going to check if the values that I'm getting, okay, now it's 0, and I'm going to cover it, almost, okay. So you can do fine tuning, but it's okay, you can, it's analog, so I have a lot of different values. If I cover it more or less, okay. And what is happening in Arduino now, of course, It's changing then the red LED, sorry. So look, now it's there, and if I start covering, look, okay, I have different values there. Okay, this is the sensor. It's not here. You can use like I use a cover. We use plastic tube, little plastic tube that you put here, so you can focus it if you want to move it to some source of light or something like that. But you can work with another thing that is reading from the world, okay, from analog things. I'm going to show you how to use the transistor. As I told you, EduBasica has one transistor that gives you up to 5 amps. That is a lot of current that you can use to move a motor or to switch on a relay, and you can do whatever. Okay, so it's a digital. Why is digital? Because I'm not going to explain you about transistor, but transistor has a base. It's a pin. It has 3 pins. The NPN, one of the types of the transistor, and this is the base. It's called. So the base is the one that manages the current in the transistor. So if you activate that base, the current is going to be going through the transistor. It's like a switch. Okay, so that's why we use transistors inside the microprocessors and the chips and everything, because it can be used like switch on and off. So I'm going to use a digital pin. This digital pin is in EduBasica is connected to this. Okay, this is the transistor, and you can see 3 pins here, and the middle one is connected to the digital port. So the digital port is going to tell the transistor it has to be activated or not. I have connected the motor. It's a DC motor to the outputs of the transistor. So I'm going to switch the motor on off. When we are talking about motors, everything is great because you can move things. If you can move things, you can open gates. You can make a parking lot for to make a project with parking lots and open and close doors, and you can move a robot with wheels. So everything is great with motors. I love motors. Okay, so I'm not going to show you all the code, but it's the only thing I'm going to do in the loop, as you can see, is I'm going to put high the transistor, the base, and I'm going to put high the LED. That's only for when I don't know if the motor is working or not. I can see that the LED is on. It means that the motor should be on too. Okay, so that's the only thing I'm going to put it on and put it off. How much time is going to be on and off the motor? Come on. 5 seconds, right? 5 seconds. Okay. So I'm going to upload this, and as soon as so 5 seconds off, 5 seconds on. So it's what happens here is digital. Can I control the speed of the motor? Not now. This transistor is going to switch it on, switch it off. That's all. I cannot say, okay, go a little slower now. Now the robot is slow. No, I cannot do that. So that's why we are using. So I want this not to be working more. I use this switch, and that's all. It's not working anymore. There's no power in here. Okay, for the motors. So that's why we include this H-bridge. It's an amplifier too, but it's great because you can control 2 motors with this chip, and you can control the speed, and you can control the direction. So you have everything there. So you can say go forward, go backward, go slower, go faster. So you have everything with this chip. Okay, it's protected with diodes, so it's great, and it's with the condensers here, condensers. So what can you do here is to connect. Another thing we learn using this class is that these pins sometimes get off. So you can, the best thing, the safest thing is to connect this with these kind of connectors. So it gets, when you're talking about motors and you have more current, it's better to have this. So this is almost the last thing I'm going to show you, I promise. Okay, now I've connected we have 2 motors. We have connected it to motor A. So I'm going to open motor. I'm connecting it to motor A. So motor A, and this is going to, we have made like a little library. So the student at the beginning, they don't have to know how it works. Later you can say, okay, go down, and you can say how all the functions works. At the beginning, you only see this: forward during 4 seconds, then stop during 2 seconds, then backward. That's all you know. That's the first stage. And then after that, you can tell them, okay, how are you getting the motor going backward or forward? You only have to, okay, explain them how to switch on or switch off certain pins, and that chip makes everything. Okay. For now, we're in the first step, so I'm not going to tell you how to do it, but I'm going to, as you can see, use a fixed velocity now. But I have velocity. So I have from 0 to 255. Now it's going to work at medium speed, but I can change it wherever I want. Okay, this test program has no change of velocity, but you can change the direction. So I'm loading it now. Now I'm going to give power to Arduino. And it's not working. Perfect. Let me see, forward.
Yeah, the switch.
No, it's an on, it's an on. Okay. The pins are, because it's an all motor and the pins are not soldered, maybe it's this. Okay, anyway, it works. I can assure you that it works. Anyway, it was, there's a lot of things that we can do it here. I have different sensors, like this one we use it for line tracking. Maybe you have seen that there are a lot of robots following a black line, so you can use with this. This is a digital sensor that tells you if it's black or it's white. So it's these two LEDs. One is sending a light, and the other one is receiving the light, so it can know when it's dark or it's bright. So it's giving you 1 or 0. If we have a temperature sensor like this, you can use it for control the temperature in a little I don't know, farm facilities. You can use this like in a pro version. Okay, there's people working with Arduino in farms, in a lot of professional environment. And okay, the last thing I'm going to use is these little motors are called servo motors. It's a very tiny thing that you can control not only the speed. You can tell the motor, okay, move to 15 degrees. So it's going to move like 15 degrees. It has a very accurate movement, so you can say move 1 degree. It's going to move 1 degree. So you can use it in a lot of applications. I have one. Okay, I have one. This sketch, this test program, what it's going to do is to read from the potentiometer, and depending on the movement that you make, it's going to read from potentiometer and it's going to write on the servo. So it's going to move as you move the potentiometer, it's going to move in the sensor. Okay. So now it's connected. Okay, I'm going to connect it to A0. Changing this, you can control it from pot, or you can control it with light. So I'm going to try both ways. First one is analog 0, and I'm going to connect this. Look, it's very easy. As we provide this for the servos, you can do in whatever other pins, because like you can see that we have different versions. There are prototypes of them, so you have a lot of connections here. It's not only one, but you can connect it like that. So that's all. You have one servo connected here, and I'm going to send the program, and it's going to move with the, okay. So now I move the pot, and look. I was waiting for it. No, wait. Okay. So you move. So you move to one side and just stop. It's following your movement. Okay? So it's great. You can make like a joystick. And the great thing is that a lot of students, you can hack things. Some students come with, hey, I have an all joystick for my PC. We open the joystick and they take out all the wires and we connect to Arduino and we move a robot with it. So it's great. They have creativity about this. And they have a lot of ideas, crazy ideas, of course, always. I'm going to do the same now with the LDR. So I'm going to move it with light. Okay? So depending on the light, you can. Okay? So that's great. So that's pretty much everything. There's a lot of experience we have been in the last years, and we are applying to our classrooms, and we are trying to make everything simpler and try to use the time the best way we can, and we have in our classes. The kids love this, okay? The kids, they love using these things. They love to program. When the first day is like, what is all these words? And the syntax is very complex the first day, but man, you have to see them in 1 week. It's awesome how they can program in C. I have like a. I will show you. This is made with EduBasica tools. A lot of things here, but you can control it. I don't know. So I need a phone. Okay, this is controlled by Bluetooth. I told you that EduBasica is prepared to connect a Bluetooth module. That is, I'm told that it's called that is $3. This Bluetooth module. This thing that is blinking here. I put this to use a camera so you can record when the robot is moving. But all these things, Arduino, the official board is like $20 that you have. It's open source, so you can buy it in Chinese things. It's not illegal because it's open source. You can build your own Arduino. And I bought the last one. It was like $9. You can get an Arduino for $9.
Wow,
It's my power. Okay, so I can connect it with with phone, because this creates the same connection as we did in the PC. Now we have a serial connection between this robot and the phone. The only thing you have to do is to pair with it. We have a light here or no? Yes. No light?
Oh, there's a switch, but I don't know where it is.
Okay.
Arduino, someone hacked it with Arduino.
So I don't know if you all can see it, but once it's connected, you can like control it, move it, and you can use this. Okay, so you can control it, control the speed, and you have even a ultrasound sensor that tells you the distance to an object, so you can avoid objects or find something. Be careful because it is going to shoot. I don't want to hurt anyone. Okay, are you ready? I don't know if you can see, but it should. It has a little servo here that same that I show you that moving and creating a shark here. It has another servo here that is opening and closing the scrolls. And now it's not connected, but you can make this moving too because it's another servo there. So you have 4-wheel drive, and we have an EduBasica there making all the work.
Is this an app?
This is a general. It's not an app that we have designed. It's a Bluetooth serial connection that creates connection with the Bluetooth, and so you can use whatever. These are some examples.
Where did you find the book?
Then
The book.
in our website, This is our website. We have everything is free. We have done the book is free. All the practice, all the test sketches we have done they're all free. So it's like we use it for working. So and in the website you can download the book. This is the website and the book is here. You have an online version that we are building. You can download it for you have in iTunes and PDF. Okay. So it's practicas con arduino.com.
Con Arduino.
Prácticas con Arduino.
Prácticas con Arduino.
Okay. If you have any question or something you want to know, yeah.
Yeah.
How long did the configuration and the setup for this take?
For that, well, this you spend the most time building the frame and all the mechanics. That is great for the students to build all that kind of things. But once you have it, maybe in one classroom you can have it moving just like you can control it, and then it's like, okay, the kids told me, hey, we can use it for shoot something. Okay, we can do it. We can make it to avoid objects or to find something. So you can add things. Okay, so there's a lot of things it's infinite things that you can make. Any other question?
Yeah. Where are you implemented this practice here in the Valley? What school?
Well, I've been doing it like in a lag version in PSDA. I'm in Southwest High School, so I'm physics teacher. It's not my field because I'm teaching another thing more related to engineering, but we have been using that for electronics, for the electronics part. So yeah, it's great. But in Spain, they are changing the law for this next year, starting a new law for education, and they have included robotics as a subject. So it's a subject now. It's not like we have to do it for physics. No. We have a subject now in Spain that is robotics, and that's awesome. That's great for the students. Okay.
Thank you.
Thank you.